Welcome to Backyard Science. My name is Marilyn. I work for the Marina Branch at the Monterey County Free Libraries, and this week we will be learning about the sun. First we'll learn some facts, and then we will study the sun by making a shadow sundial. So, what do we know about the sun? We learned about it a little bit last week in our wonderful wind video. We know that the sun heats land and sea at different rates, creating different air temperatures, and with the rotation of the earth causes the warm air to rise and the cool air to come in and replace it, creating wind. But there are lots of other ways that the sun affects our lives. The first thing you need to remember is that even with sunglasses, never look directly at the sun. It can damage your eyes very severely, so keep that in mind as you're doing our activity this week. First, some facts. The first thing that you need to learn about the sun that is not readily obvious is that it is actually a star. I know. The sun is actually the same kind of object as the little tiny pinpricks of light that we see up in the night sky. It's just much, much, much closer than those distant stars. But still, it's not that close, relatively. It is about 150 million kilometers, or 93 million miles, from the Earth's surface. Now, think for a second. Imagine turning on a lamp or a flashlight in a dark room. How fast does the light light up the room? Pretty instantaneously, right? That's because light travels at 186,000 miles per second, or 300,000 kilometers per second, which is pretty darn fast. Even still, the light from the sun takes 8 minutes to reach us, which gives you some idea of how far away the sun is from the Earth's surface. The sun is made of gas, like all stars. It is very densely packed and extremely hot. It is so hot that it is not even a gas anymore, but a soupy substance called plasma. When you say plasma, it's a pretty awesome word. The sun is also the biggest and most powerful object in our solar system. At its widest point, 109 Earths could fit across it, and about 1 million Earths could fit inside. So to give you an idea, here is my appropriately yellow sphere that I have in my house, and if you imagine that this is the sun, I measured this object and I calculated the diameter to be 7 centimeters long, and which is a little over 3 inches, and so 100th of that diameter is 0.7 millimeters. So this is even a little bigger than that, but this little piece of paper is how big the Earth is compared to the sun, about. So that gives you some idea of the massive scale of the sun. At its surface, it is 10,000 degrees Fahrenheit and 5,600 degrees Celsius. If you think of a pot of boiling water, that is 100 degrees Celsius. So that gives you some idea of how hot it is. And then at its core, it is 15 million degrees Celsius. Now the core is where nuclear fusion happens. Nuclear fusion is the reaction that causes the immense energy that the sun gets its heat from, which is hydrogen being changed into helium, which sounds easy, but it's really, really not. Oh, we know a lot of these things about the sun and many more things because of the Solar and Heliospheric Observatory, which is a satellite that was launched in 1995 by NASA. But let's come back to the backyard for a second. What was it like before we had all these really fancy instruments to measure and look at the sun? Our ancestors didn't know a lot of things about the sun. All they knew was what they observed. So these are some interesting principles that we will go back to for our activity today. Our forebears saw that the sun seemed to move. It seemed to rise in the east and set in the west. So for a long time, people thought that the Earth was still and that everything else was moving around it. They also observed that the temperatures changed throughout the seasons, depending on what part of the earth they were on, and that the days got longer or shorter depending on the season as well. Now we're going to practice looking at how the sun appears to us by making a shadow sundial. Now we're going to make our shadow sundial. What you will need is something to measure with, a pencil, a nature journal or piece of paper, something to draw or measure your shadow. I have a rock that I'm going to place at the top to be able to measure and see, but you can also use sidewalk chalk or something to draw on. Pavement is definitely a good put thing if you have that. Make sure you also mark the place where you're standing. I have a place where the concrete slabs come together. That is my marker. But you can mark it with a rock or sidewalk chalk, and just make sure you stand in the same place every time. And what you do is you come out either at 9 a.m. or noon. Seems to be a good starting point where you can really see the difference. And you're going to stand tall and get someone to either draw your shadow, trace your shadow, or place a rock at the very top. And you can measure the height of your shadow in your journal at different times. And we will come out every half hour and measure the shadow and make observations about it. And that will tell us how the sun appears to move in the sky. My shadow right now is my feet on my little concrete things. So I'll come back to this exact spot, and then there's my shadow and the little rock that I put. And I'll measure that height and write it down. And then we'll come back out at different times and see what these different shadows look like. And remember, you can always use, I don't have any, but you can always use sidewalk chalk to trace your shadow. Alright, so we'll see you in half an hour. Here are the rocks for our sundial clock. I think the heights are a little imperfect because I had my hat on, but you can see there is 12:30, 1, 1:30, 2, 2:30, 3, and then I missed a couple of half hours, and that's 4:30. So you can see as it gets later in the day that the rate of movement starts to get more, because that is definitely further apart than, say, these two. So yeah, there is our sundial clock. And you can make yours with sidewalk chalk, whatever you can. Here is my nature journal entry. You can draw more pictures if you would like, but I have the times and the lengths in centimeters for my experiment. So as the day went on, I saw my shadow get longer as the sun seemed to get lower in the sky. If you started in the morning, your shadow would start long and get shorter as the sun got closer to directly overhead at noon. Something to keep in mind is if you do this activity at different places on the sphere of the earth, you're going to get different results. Your shadow might look more squishy or more tall at different times of the day. And the angles are also going to be different for the distance that the sun moves. The reason this happens is because of the rotation of the earth and the way it rotates around the sun. So that's what makes it seem like the sun is moving. If our planet didn't rotate, the sun would be shining on one place all the time, and life on Earth would be very different. that concludes our Splendid Sun episode. I hope you had a lot of fun learning about our nearest and dearest star. Don't forget to go check out the SOHO website at nasa.gov. They have a lot of really neat images concerning the research about the sun. And you can also check out the library website for the World Book and Britannica sections that have a lot of really interesting information. I hope this inspires you to ask questions about what you see in your backyard. Thanks for tuning in and have fun exploring. Bye.